Hello, Mr. Myas here, and this video we're going to look at rational functions and their vertical asymptotes. So we're going to find vertical asymptotes looking at them algebraically and thinking about why they happen. So just a couple of notes. What is an asymptote? Well, an asymptote is something that cannot be crossed or doesn't really cross. The graph itself doesn't cross the asymptote because it's not in the domain or it's not in the range. Horizontal asymptotes are a little bit different. We'll talk about in the next video. So, for vertical asymptotes, it's a vertical line, x equals c, in which the graph will approach, but it will never cross. This is because that line, x equals c, is not in the domain of the function. We can find that by taking the denominator of any rational function and setting it equal to 0 and solving for x. If we have something else that has a vertical asymptote that's not rational, we need to do some other things. But in this case, we're just dealing with rational functions. So let's take a look at one. F of x equals 1 over x squared minus 4. Now, if you watched an earlier video of mine when we talked about graphing rational functions using a step-by-step approach with the composite functions, you saw that the previous graph had zeros at -2 and 2. And at those zeros, at those x-intercepts, we created vertical asymptotes. Well, why does that happen? That happens because x squared minus 4 is going to give you those x-intercepts when y equals 0. Well, when you take the reciprocal of that, you're going to have 1 over 0, which we all know will destroy the universe. Unless, of course, you're Chuck Norris. But we don't want that to happen, so we draw vertical asymptotes. And our graph is going to look like this. Again, if you want to, you can go back and take a look at that video, and you'll see how we come up with this graph without using a graphic calculator. But let's take a look at this graph. If we look at the graph, we notice here that the vertical asymptotes are at x equals 2 and x equals -2. Well, that occurs because we do not want the denominator to be 0. So we can find the vertical asymptotes by simply taking the denominator, x squared minus 4, and setting it equal to 0. And solve for x. So we get x squared equals 4. Take the plus or minus square root of both sides. And we get two vertical asymptotes, x equals 2 and x equals -2, and those are our vertical asymptotes. That's all there is to it. Let's take a look at a couple more examples. We have the function f of x equals 3x over x minus 5. So we're interested in finding the vertical asymptote. So we're going to take the denominator, x minus 5, set it equal to 0, and we're going to get x equals 5. This is our vertical asymptote. One of the things that students do that is a real pet peeve of mine, I can't speak for other math teachers, but it's a pet peeve of my students, it's a pet peeve of mine that my students do, is they tend to write their answer as VA5. That doesn't really make any sense. VA:5 doesn't make sense. Even if you made that equal to 5, that still doesn't make any sense because VA is not one of our axes in our coordinate plane. Clearly, it should be x or y. So, please, I implore you, when you write your equations, write them as x equal 5. If you're my student, I would appreciate it. And if you're somebody else's student, I believe your teacher or professor will like that too. So, I got one more example for you. 2x minus 3 over 2x squared plus x minus 1. Again, vertical asymptote. We're going to take the denominator and set it equal to 0. For this one, we're going to need a factor. So we're going to get 2x minus 1 and x plus 1. Each of these, we'll set them both equal to 0. And we're going to get x equals 1/2 and x equals -1. And in this case, this function here has 2 vertical asymptotes, similar to the first one we did. All right, that's vertical asymptotes. See you later.